Hello everyone, in this video we'll be studying chemical reactions and equations. This is the first chapter of class 10 science. So let's begin. The topics we'll be covering in this video are chemical reactions, characteristics of chemical reactions, chemical equations, types of chemical reactions and effects of oxidation in life. So I'll be explaining everything to you in detail. Let's begin. First, let's talk about chemical reactions. Chemical reactions. The transformation of a chemical substance into another chemical substance is known as chemical reaction. Like when you breathe, you convert the oxygen which you inhale into carbon dioxide, which cannot be reversed by physical processes. That is why it's known a chemical reaction. In a chemical reaction, a new substance is formed which is completely different in properties from the original substance. So in a chemical reaction, a chemical change takes place. Okay, so when you inhale the oxygen and when you exhale the carbon dioxide is a new substance which is completely different in properties from oxygen, which was the original substance. Only a rearrangement of atoms takes place in a chemical reaction, meaning uh, only the atoms get rearranged into a molecule and make a new substance. So the substances which take part in a chemical reaction are called reactants, and the new substance produced as a result of the chemical reaction are called products. Now let's talk about characteristics of chemical reactions. A chemical reaction can be determined with the help of any following five observations. Meaning, if you have observed any five of these things, you can say that a chemical reaction is occurring. Evolution of gas. I'll give you examples for all of them. So, evolution of gas. In the chemical reaction between zinc and dilute sulfuric acid, uh, there is evolution of the hydrogen gas. Change in color. The chemical reaction between sulfur dioxide gas and acidified potassium dichromate solution is characterized by a change in color from orange to green. So in these two cases, you can see by the evolution of gas and change in color that chemical reactions have taken place. Next, change in state of substance. So when you burn a candle, the candle wax, which was solid, turns to water and carbon dioxide, which are liquid and gas due to combustion. Change in temperature. The chemical reaction between zinc and dilute sulfuric acid again is characterized by a rise in temperature and forming of precipitate, meaning basically uh, a solid substance precipitates, meaning basically undissolves out of the solution. So the chemical reaction between sulfuric acid and barium chloride solution is characterized by the formation of a white precipitate of barium sulfate. All these five things signify that there is a chemical reaction which has taken place. Let's talk about chemical equations. We already are familiar with chemical equations since like class 9. Uh, when you use symbols to represent a chemical reaction, it is called a chemical equation. So in this example, A plus B is turns into C plus D. A and B are called reactants, and C and D are called the products. The arrow shows the direction of the chemical reaction. Okay, so when hydrogen reacts with oxygen, it gives water. You can represent this as a chemical equation as H2 plus O2 equals H2O, meaning a hydrogen atom when reacts with an oxygen atom produces a water molecule. Hydrogen molecule when reacts with an oxygen molecule produces a water molecule. Okay, so in the first one, hydrogen plus oxygen equals water. Uh, Words are used, but in the second, symbols are used. Symbols actually help you write chemical equations easily, so they're convenient. Now let's talk about balanced chemical equations. When there is when a chemical reaction has taken place, the left side of equation in number of atoms must be equal to the right side of equation in number of atoms. Here we can see zinc plus H2SO4 turns into ZnSO4 plus H2. So as you can see, there's only one number of zinc atom in both on both the sides, one number of sulfate atoms on both the sides, and one number of hydrogen atoms on both the sides. So it's equal on both the sides. That's why it's called balanced chemical equation. According to the law of conservation of mass, mass can neither be created nor destroyed in chemical reaction. To obey this law, the total mass of elements present in reactants must be equal to the total mass of elements present in the products. Okay, understood so far. You can look at the table if you got confused. Now, unbalanced chemical equations. Uh, if the number of atoms of each element in reactants is not equal to the number of atoms of each element present in the product, then the chemical equation is called an unbalanced chemical equation. In the example given, uh, towards the reactant side, there's one iron atom, but on the products, there are three iron atoms. There are two hydrogen atoms on both the sides, and there is one oxygen atom on the LHS and four on the RHS. Now, to balance this equation, we must first write the equation. Then this part is important, so I'll be making a video in future covering this. Let me know in the comments if you want a detailed like video about balancing an unbalanced equation. So uh, here we can multiply the H2O by 4 to make the oxygen atoms equal the number of oxygen atoms on the RHS. So there are 4 oxygen atoms. Now when you multiply H2O by 4, the number of hydrogen atom becomes 8 on the LHS. So to balance it, you need to multiply the hydrogen atom on the right hand side by 4. So after that, there are 3 iron atoms on the RHS and one iron atom on the LHS. So what you can do here is multiply the iron on the LHS by 3, so it turns into 3Fe plus 4H2O is Fe3O4 plus 4H2. Okay, so this is how you balance an unbalanced equation. Again, I'll be uploading a detailed video on this. Now let's talk about how to make equations more informative. By writing the physical states of substances, a chemical equation becomes more informative. So you can represent the gaseous state by G, liquid state by L, solid state by S, aqueous meaning a solution of or containing water is aqueous, can be written by AQ, and you can write the condition in which the reaction takes place. The condition is generally written above and or below the arrow of a chemical equation. So by writing the symbols, you make a chemical equation more informative. Next, we have types of chemical reactions. This topic is really important. You should memorize all the types of chemical reactions. Many also have subtopics which also have to be memorized. So first we have combination reaction. By the name itself, we can see that when two or more reactants combine to form one product, the reaction is called a combination reaction. Generally, you can represent it as A plus B equals AB. So here's an example. When magnesium is burned in the air, magnesium oxide is formed. So in this reaction, magnesium is combining with oxygen. So Mg plus O2 equals 2MgO. This is a type of combination reaction. Next, let's talk about decomposition reaction. A, a decomposition reaction, again, as the name suggests, is when a compound decomposes into two or more compounds or elements. A decomposition reaction is just the opposite of combination reaction. We can represent it as AB equals A plus B. There are three types of decomposition reactions. Let me talk about all of them. Thermal decomposition. Thermal decomposition is when the decomposition of substance takes place on heating it. For example, uh, CaCO3, when you heat it, it produces CO plus CO2. CaCO, CaO plus CO2. Now, electrolyte decomposition. We have already learned about this in 8th grade, I think. It's a reaction in which compounds decompose into simpler compounds because of passing of electricity. And then we have photolysis or photodecomposition reaction. Reactions in which a compound decomposes because of sunlight are known as photolysis or photodecomposition reactions. I have not given examples in these, but if you want to look at examples, you can either check from your textbook or you can go on the internet and search it out. Next, we have displacement reaction. In this, the chemical reactions in which a more reactive element displaces a less reactive element from a compound is known as displacement reactions. Displacement reactions are also known as substitution reaction or single displacement slash replacement reactions. A general displacement reaction can be represented as A plus B equals AC plus B. Basically here A replaces B as A is more reactive than B. So A forms a compound with C and gives the result B. Displacement reaction takes place only when A is more reactive than B. If B is more reactive than A, then A will not displace C from the BC and the reaction will not be taking place. Okay, understood. Now, double displacement reaction. Reactions in which ions are exchanged between two reactants forming new compounds are called double displacement reactions. AB plus CD equals AC plus BD. This has two subcategories. One is the precipitate reaction, which is the reaction in which precipitate is formed by the mixing of aqueous solution of two salts is called precipitation reaction. Then we have neutralization reaction. The reaction in which an acid reacts with a base to form salt and water by an exchange of ions is called neutralization reaction. Next, moving on to oxidation and reducing reactions. Oxidation is addition of oxygen or non-metallic element or removal of hydrogen or metallic element from a compound. Elements or compounds in which oxygen or non-metallic element is added or hydrogen or metallic element is removed are called to be oxidized. Okay. Reduction. Addition of hydrogen or metallic element or removal of oxygen or non-metallic element from compound is called reduction. Basically, it's the opposite of oxidation. The compound or element which goes under reduction is called to be reduced. Oxidation and reduction take place together. Now, oxidizing agent. The substance which gives oxygen for oxidation is called an oxidizing agent. The substance which removes hydrogen is also called an oxidizing agent because oxidation is the addition of oxygen or removal of hydrogen. And then we have a reducing agent. The substance which gives hydrogen for reaction is called a reducing agent, and the substance which removes oxygen is also called a reducing agent because reduction is the addition of hydrogen or removal of oxygen. So in reactions in which oxidation and reduction both take place simultaneously is called redox reaction. When copper oxide is heated with hydrogen, then copper metal and hydrogen are formed. So CuO plus H2 turns into Cu plus H2O. Copper oxide plus hydrogen equals copper plus water. So in this reaction, CuO is changing into Cu, meaning oxygen is being removed from copper oxide, and removal of oxygen from a substance is called reduction. So copper oxide is being reduced to copper. And in the second part of the reaction, uh, H2 is changing to H2O. So oxygen is being added to hydrogen. Addition of oxygen to a substance is called oxidation. So hydrogen is being oxidized to water. So the substance which gets oxidized is the reducing agent. The substance which gets reduced is the oxidizing agent. Moving on, we have exothermic and endothermic reactions. Don't get confused between the two, but these are very simple to remember. Exothermic reactions. Reaction which produces energy is called exothermic reaction. Most of the decomposition reactions are exothermic. Basically, a reaction which produces heat, like zinc granules plus dilute hydrochloric sulfuric acid produces heat. So it's an exothermic reaction. But an endothermic reaction is a chemical reaction in which heat energy is absorbed. Okay, so when heat energy is absorbed, it's called an endothermic reaction. Moving on, effects of oxidation in real life. So, corrosion, the process of slow conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acids, gases, etc. present in the atmosphere is called corrosion. You must have heard about the rusting of iron. Rusting of iron is also a type of corrosion. Corrosion or rusting weakens the iron and steel objects and structures such as railings, car bodies, bridges, and ships, and cuts short their life. Now, the methods to prevent rusting are painting, greasing and oiling, and galvanization, meaning the process of applying zinc coating to iron. Rusting of iron. Uh, the formula for this is 4Fe plus 3O2 plus 2xH2 2 times H2O turns into 2F2O3 times H2O. Okay, moving on. Corrosion of copper. Copper objects lose their luster and shine after some time because the surface of these objects acquires a green coating of basic copper carbonate when exposed to air. Here's the formula, you can read it if you want to. And then moving on, silver corrosion. So the surface of silver metal gets tarnished or becomes dull on exposure to air due to the formation of a coating of black silver sulfide on surface by the action of hydrogen sulfide gas present in the air. Here's the reaction equation again, you can read it if you want to. And then the last topic is rancidity. Rancidity is when the taste and odor of food materials containing fat and oil changes when left exposed to air for a long time. This is called rancidity. It is caused due to oxidation of fat and oil present in food materials. Methods to prevent rancidity are by adding antioxidant, vacuum packing, replacing air by nitrogen, and refrigeration of foodstuff. Thank you for watching the video. I'll be uploading more videos based on SST and science topics. So if you want to, you can give me a subscribe if you enjoyed my content. Anyways, thank you guys. I'll meet you again.